So now when we take a look at naming this carbon chain, we want to now take a look at what about the attachment groups and how do we incorporate them into the name of our alkenes and our alkynes. And so in this case over here, one of the things that you want to make a note of in this very first point is that the parent chain must contain that double and triple bond. And so we need to ensure that when we find that parent chain, we have to have that double and triple bond present in it. So in this case, if we were to take a look at an example, so I'm going to draw a line diagram over here, and I'm going to have a double bond right here in the main carbon chain, and then I have something like, for example, a CH3. And if I was to count this, I'm going to count 1, 2, 3, 4, 5, 6, 7, or the reverse is 1, 2, 3, 4, 5, 6, 7. Now, if we were to take a look at the molecule here, we kind of have now competing priorities, because if you were to take a look at the numbering from right to left, or left to right, sorry, that the methyl group gets a smaller number here, and you have this double bond which has the relatively larger number compared to if I was looking at the right to left numbering. And so in this case over here, going from right to left, the double bond gets a smaller of the number pairing, but it gives a larger number to the attachment group. So which one gets priority? And so in this case, the principle here is anything that is incorporated within the main chain is going to have priority over whatever is attached to it. And so in this case over here, because this double bond over here has a smaller number, then what we're going to be looking at is the right to left as the primary way that we're going to be numbering our carbon chains, so that the double bond here gets the lower number. And so in this case over here, this again is our methyl group. We have a 7-carbon chain, so this will be a hept. And since there's a double bond, there will be an ene, and this double bond is at the 3rd carbon. So how do we then go about naming this? And so in this case, we're going to first of all write the location of the methyl group, which is going to be at 6. So this will be 6-methyl. And then we're going to be writing the location of the double bond. So this one here is going to be 3, and this will be heptene. And that will be the name of this double bond molecule. So if I were to do one more example, so in this case over here, I'm going to draw this one. And I am going to be putting, let's say, a triple bond right over here. And let's say I'm going to put in, on this end right here, a BR. And so in this case, if I was to number this main chain, this would be 1, 2, 3, 4, 5, 6, 7, 8. And on the other direction, this would be 1, 2, 3, 4, 5, 6, 7, 8. So as you can see, going from left to right, this triple bond gets the smaller numerical combination compared to if I go from right to left. And so therefore, I must choose the top way going from left to right to number this carbon chain. And so if I was to write the name of this, this will be 6-bromo. And then I'm going to have 2-octyne. So the final one, just as something that's a little bit trickier, is if I was to draw this molecule right over here. And let's say at this point, I'm going to be putting 2 double bonds. And then let's say over here, I am going to be putting in, let's say, an F. So I'm going to have 1, 2, 3, 4, 5, 6, 7. Going backwards, this is 1, 2, 3, 4, 5, 6, 7. Going from left to right gives me the lower numerical combinations for my 2 double bonds in the main chain. thus forcing this left to right direction of numbering my carbons and giving my fluoro group over here the 6 carbon location. So how do I write this? This will be 6 fluoro, and then if I take a look, this first double bond is at the 2nd carbon, this one is at the 4th carbon, so it'll be a 2, 4, and then in this case, this is 7 carbons, so it's going to be a hept, and it's going to be a hepta, and then there's going to be 2 double bonds, so it's going to be diene. So this molecule is 6 fluoro, 2, 4 hepta diene. And so you can see that once we get the fundamentals, what we're doing is we're just building on the naming of these molecules.